Good day, I am Wendy Alabastro, and today I will be discussing Chapter 4, Discrete Probability Distribution, Section 4.1, Probability Distribution. So to start this lesson, we will first identify the objectives of this lesson. So here are the objectives. First, how to distinguish between discrete random variables and continuous random variables. Second, how to construct a discrete probability distribution and its graph, and how to determine if a distribution is a probability distribution. Third, how to find the mean, variance, and standard deviation of a discrete probability distribution. And finally, how to find the expected value of a discrete probability distribution. So now let's start discussing about the random variable. What is a random variable? So a random variable represents a numerical value associated with each outcome of a probability distribution. It is denoted by x. So here are the examples. First, x is equal to the number of sales calls a salesperson makes in one day. So our random variable here is this one, the number of sales calls a salesperson makes in one day. Another example is x is equal to r spent on sales calls in one day. So our random variable here is the r spent on sales calls in one day. So there are two types of random variable. First is the discrete random variable. So a discrete random variable has a finite or countable number of possible outcomes that can be listed. Example is x is equal to the number of sales calls a salesperson makes in one day. So here is the number line. It means that it is countable. So our number line here has the label of 0, 1, 2, 3, 4, and 5. Then another type of random variable is continuous random variable. It has an uncountable number of possible outcomes represented by an interval on the number line. So our example is x is equal to the r spent on sales calls in one day. And under that is another number line, but since continuous random variable is represented by an interval, so our interval here is from 0 up to 24, since there are 24 hours in one day. So now let's proceed to the other examples. So determine whether each random variable x is discrete or continuous. Explain your reasoning. So first, let x represent the number of Fortune 500 companies that lost money in the previous year. So solution. The example is a discrete random variable. Why? Because the number of companies that lost money in the previous year can be counted. So under that is a number line with the label 0, 1, 2, 3 up to 500. Another example is, let x represent the volume of gasoline in a 21-gallon tank. Solution. The example is a continuous random variable because the amount of gasoline in the tank can be any volume between 0 gallons and 21 gallons. So volume cannot be counted. So this means that our interval is just between 0 gallons up to and 21 gallons. So next, let's proceed to the discrete probability distributions. Discrete probability distribution lists each possible value the random variable can assume together with its probability. And it must satisfy the following conditions. First, the probability of each value of the discrete random variable is between 0 and 1 inclusive. Or in symbol, it is P of x is less than or equal to 0, but P of x is greater than or equal to 0 or less than or equal to 1. Next condition is the sum of all probabilities is 1, or in symbol, it is summation of P of x is equal to 1. Now, here are the Steps in constructing a discrete probability distribution. Let x be a discrete random variable with possible outcomes x sub 1, x sub 2, x sub n. So first, let's make a frequency distribution for the possible outcomes, and then find the sum of the frequencies. After that, we will find the probability of each possible outcome by dividing its frequency by the sum of the frequencies. And then lastly, check that each probability is between 0 and 1 inclusive, and that the sum of all the probabilities is 1. So this last step, it says that it must satisfy the two conditions to be said that the probability distribution is a discrete probability distribution. So now let's have an example. An industrial psychologist administered a personality inventory test for passive-aggressive traits to 150 employees. Each individual was given a whole number score from 1 to 5, where 1 is extremely passive and 5 is extremely aggressive. A score of 3 indicated neither trait. The results are shown. Construct a probability distribution for the random variable x, then graph the distribution using a histogram. So here, the table here has the score x and then the frequency f or f. So the score 1 has a frequency of 24. Score 2 has a frequency of 33. Score 3 has a frequency of 42, and then score 4 has a frequency of 30, and then score 5 has a frequency of 21. Solution. So, divide the frequency of each score by the total number of individuals in the study to find the probability for each value of random variable. So, P of 1, this is our first random variable, is equal to 24 over 150. So the 150 here is the total frequency, is equal to 0.16. P of 2 is equal to 33 over 150 is equal to 0.22. P of 3 is equal to 42 over 150 is equal to 28. P of 4 is equal to 30 over 150 is equal to 0.20. P of 5 is equal to 21 over 150 is equal to 0.14. So, this one is the probability of for each value of the random variable. So now, let's proceed in making the discrete probability distribution table. So, x, and then we have here the x and the p of x. So, first, P of 1 is equal to 0.16, P of 2 is 0.22, P of 3 is 0.28, P of 4 is 0.20, and then P of 5 is 0.14. And then, let's now validate if the probability distribution table is indeed a discrete probability distribution. So, this is a valid discrete probability distribution since each probability is between 0 and 1 inclusive. So as you can observe that all the values are between 0 and 1. And then the sum of the probabilities equals 1. So the summation of P of x is equal to 0.16 plus 0.22 plus 0.28 plus 0.20 plus 0.14 is equal to 1. Then, because the width of each bar is 1, the area of each bar is equal to the probability of a particular outcome. Also, the probability of an event corresponds to the sum of the areas of the outcomes included in the event. So this graph is a histogram. So as you can see that the score number 3 is the highest. So this graph you can see that the distribution is approximately symmetric. So now let's proceed to another example in verifying a probability distribution. Verify that the distribution for the 3-day forecast and the number of days of rain is a probability distribution. So our random variable here is the days of rain, 0, 1, 2, and 3 with its corresponding probability. So probability of 0 is 0.216. The probability of 1 is 0.432. The probability of 2 is 0.288. The probability of 3 is 0.064. Solution. If the distribution is a probability distribution, then it must satisfy the two conditions, which are each probability is between 0 and 1 inclusive, and then the sum of all the probabilities is equal to 0. So, as you can see, that the values of the probabilities are between 0 and 1. So, therefore, that because both conditions are met, the distribution is a probability distribution. So, 0.216 plus 0.432 plus 0.288 plus 0.064 is equal to 1. So, it satisfies also the condition number 2. So, next. Example in identifying probability distribution. So, determine whether each distribution is a probability distribution. Explain your reasoning. So, we have here a probability distribution table. Our random variable here are 5, 6, 7, and 8. The probability of 5 is 0.28. Probability of 6 is 0.21. The probability of 7 is 0.43. And the probability of 8 is 0.15. So, solution. Each probability is between 0 and 1, but the sum of all the probabilities is 1.07, which is greater than 1. Therefore, the sum of all probabilities in a probability distribution always equals to 1. So, this distribution is not a probability distribution because it doesn't satisfy the condition number 2. So, let's have another example. Our random variable here are 1, 2, 3, and 4. The probability of 1 is 1/2. The probability of 2 is 1/4. The probability of 3 is 5/4. And the probability of 4 is -1. So, the sum of all probabilities is equal to 1. But P of 3 and P of 4 are not between 0 and 1. So, this probability distribution doesn't satisfy the first condition. The probabilities can never be a negative or greater than 1. So, this distribution is not a probability distribution. Let's proceed to the mean of a discrete probability distribution. So, to find the mean of a discrete probability distribution, we use this formula. Mean is equal to the summation of x times the probability of x, where each value of x is multiplied by its corresponding probability and the products are added. So now, let's proceed to the example in finding the mean. The probability distribution for the personality inventory test for passive-aggressive traits is given. Find the mean score. So, solution. Here our table. X, P of x, and then the third table is the value when we multiply this one. So, x, P of x. So, first, 1 times 0.16 is equal to 0.16. 2 times 0.22 is equal to 0.44. 3 times 0.28 is 0.84. 4 times 0.20 is equal to 0.80. 5 times 0.14 is equal to 0.70. So, using the formula in finding the mean, we will add this value. So, 0.16, 0.44, 0.16 plus 0.44 plus 0.84 plus 0.80 plus 0.70 is equal to 2.94 or approximately 2.9. So, this one is our mean. So, here it is. So, our mean is equal to the summation of x times p of x is equal to 2.94 or approximately 2.9. Recall that a score of 3 represents an individual who exhibits neither passive nor aggressive traits, and the mean is slightly less than 3. So the mean personality trait is neither extremely passive nor extremely aggressive, but is slightly closer to passive. Okay, next, let's proceed to the variance and standard deviation. To find the variance of a discrete probability distribution, we will use this formula. Variance is equal to the summation of x minus mean quantity squared times the probability of x. And then, in finding the standard deviation of a discrete probability distribution, we will use this formula. Standard deviation is equal to the square root of variance is equal to the square root of summation of x minus mean quantity squared times the probability of x. So, here, the probability distribution for the personality inventory test for passive-aggressive traits is given. Find the variance and standard deviation. So, this is the probability distribution table. So, score with the score, our random variable with its corresponding probability. And then let's proceed and we will recall that our mean is 2.94. So, here it is. So, our first column is the random variable, and then second column is the probability, and then our third column is the values the values or the difference of x minus mean. So, 1 minus 2.94 is equal to negative 194. 2 minus 2.94 is equal to negative 0.94. 3 minus 2.94 is equal to 0.06. 4 minus 2.94 is 1.06. 5 minus 2.94 is equal to 2.06. So on our fourth column, we will square the values in the third column. So negative 1.94 squared is equal to 3.764. Negative 0.94 squared is equal to 0.884. 0.06 squared is equal to 0.004. 1.06 squared is equal to 1.124. 2.06 squared is equal to 4.244. And then, on our fifth column, is that we will multiply the values in the fourth column to its probability, this one. So multiply the fourth column to the second column. So 3.764 times 0.16 is equal to 0.602. 0.884 times 0.22 is equal to 0.194. 0.004 times 0.28 is equal to 0.001. 1.124 times 0.20 is equal to 0.225. 4.244 times 0.14 is equal to 0.594. So now we will find the variance using the formula. Variance is equal to the summation of x minus mean quantity squared times p of x. So we will add the values in the fifth column. So 0.602 plus 0.194 plus 0.001 plus 0.225 plus 0.594 is equal to 0.6164. So 1.6164 is our variance. And then now, let's proceed in finding the standard deviation using the formulas. Standard deviation is equal to the square root of variance is equal to the square root of 1.6164 is approximately 1.3. Most of the data values differ from the mean by no more than 1.3. So that is the standard deviation. Let's proceed to the expected value of a discrete random variable. So expected value is equal to the mean of the random variable. E of x is equal to mean is equal to summation of x times the probability of x. Now, let's have a example in finding an expected value. At a raffle, 1,500 tickets are sold at $2 each for 4 prizes of $500, $250, $150, and $75. You buy one ticket. Find the expected value and interpret its meaning. So, solution. To find the gain for each price, subtract the price of the ticket from the price. So, first, your gain for the $500 price is $500. This is the price. And then, minus the $2 is the price of the ticket. So, is equal to $498. Your gain for the $250 price is $250 minus $2 is equal to $248. Your gain for the 150 price is $150 minus $2 is equal to $148. Your gain for the $75 price is $75 minus $2 is equal to $73. If you do not win a prize, your gain is $0 minus $2 is equal to negative $2. So, let's make a probability distribution table for the possible gains or outcomes. So, our random variable here is the gain, which with its corresponding probabilities. So, the $498 has a probability of 1 over 1,500. $248 has a probability of 1 over 1,500. $148 has the probability of 1 over 1,500. $73 has the probability of 1 over 1,500. And then negative $2 is the probability of 1,496 over 1,500. Now, let's get the expected value. So, E of x is equal to the summation of x times P of x. So, this means that we will multiply the gain with its or our random variable with its corresponding probabilities. So, it is equal to $498 times 1 over 1,500 plus $248 times 1 over 1,500 plus $148 times times 1 over 1,500 plus $73 times 1 over 1,500 plus negative $2 times 1,496 over 1,500, which is equal to negative $1.35. So this means that you can expect to lose an average of $1.35 for each ticket you buy. So, that's all for the section 4.1 entitled Probability Distribution of Discrete Probability Distribution. Thank you and God bless.